Let's look at one of the most famous solutions to the St. Petersburg paradox. By the way, the St. Petersburg game was invented by a fellow by the name of Nicolas Bernoulli way back in the 1700s, and he discussed it with one of his cousins named Daniel Bernoulli. And Daniel Bernoulli published the solution that we're about to discuss in a journal called the St. Petersburg Academy Proceedings, which is how the puzzle got its name. So what was Bernoulli's solution? Well, he said, we've been making the mistake of working with monetary value instead of utility. We should calculate expected utility instead of expected monetary value. How does that help? Well, Bernoulli's idea was that even though the payoffs increase by doubling as the game goes on longer, goes from $2 to $4 to $8 and so on, the utilities increase more slowly. As we've discussed previously, as dollars increase, utility increases too, but not quite as quickly. And Bernoulli's idea was that utility increases logarithmically with dollars. In other words, the utility of $2 is actually the logarithm of $2, and the utility of $4 is the logarithm of $4, and so on. And that gives us this curve we've seen before on the slide, where the x-axis is dollars and the y-axis is utility measured in logarithm of dollars. Now, if Bernoulli is right that utility increases logarithmically with dollars, then $16, for example, is not twice as valuable as $8, because the logarithm of 16 is not twice the logarithm of 8. To get twice the logarithm of 8, you'd have to go all the way up to $64. And that's because logarithms have the general property that the logarithm of a to the b is b times the logarithm of a. In other words, the logarithm of 8 squared, which is 64, is equal to 2 times the logarithm of 8. So that would mean that the utility of $64 is twice the utility of $8. So what Bernoulli did in his famous paper on the St. Petersburg paradox is he calculated the expected utility of the St. Petersburg game, assuming that the utility of x dollars is just the logarithm of x. And what that does is it takes an infinite expected monetary value and turns it into a finite expected utility. On the slide here on the left, you can see the expected monetary value. That's the area of the blue region on the left. And on the right is the expected utility. That's the region of the blue area on the right. What Bernoulli found when he worked out the arithmetic then is that the expected utility comes out to about 1.4, which makes sense. Not only is that a finite number now, but it's also approximately the logarithm of 4, which means that it makes sense that people would be willing to pay about $4 for the St. Petersburg game, because that's the expected utility, under the assumption that utility and money are related by the logarithm function, or something probably close to it.